Hello and welcome to lesson 21, where we are looking today at the discriminant. So today's lesson is short, so we're mostly practicing, but it's a really important lesson because the discriminant is a really helpful tool for us. So today we're going to make, for our learning goal, we are going to make connections from the number of real roots of a quadratic function to the discriminant value, and as well as make connections to the quadratic formula. So for a warm up, first look at these first three functions and try to determine if they're factorable over integers. So can we try decomposition method or the sum and product to be able to write these in factored form? So you should have got that the first function is factorable and get x minus 2 and times x minus 3. The second function, if you try to find two numbers who have a product of 14 and a sum of 3, you would have not been able to find any. So no solutions there, it's not factorable. And for the last one, it's a perfect square with -2. And again, that comes from that -4x. So, what methods could you have used to factor each of these or to solve them? And which method would always work? So definitely graphing these, you would have been able to solve them. You would have seen the x-intercepts based on the graph. And if you remember, you had a hint on the page there as well, quadratic formula. Quadratic formula will always give us the solution to any quadratic function. So that's your method that's always going to work. I know it's a little bit tedious to use at times, but it's very helpful. And I have attached the link there for you. If you forgot that lesson, please take a moment to review it because it was from Unit 1. So, a little bit of review here as well. Having a quadratic function in standard form, so ax squared plus bx plus c is equal to 0. Our quadratic formula tells us that the solution to this equation is going to be two possible solutions, so x1 and x2, but we can obtain it from this formula, which is -b plus or minus b squared minus 4ac over 2a. And all of this, the ABCs come from the ABCs of your standard form. So now we're getting introduced to the discriminant. So the discriminant is the expression is shown by the expression or the equation d is equal to b squared minus 4ac. And that should be familiar to you because it was from over here. We see that b squared minus 4ac. And it's from the quadratic formula, and it helps us determine the number and nature of roots or the solutions of a quadratic formula. So what does the number and nature of roots mean? So, if you find d to be greater than 0, you can conclude that your function has two real solutions, which means that for our x-axis being there, you will have, for example, a parabola going that way or the like opposite way, like it can have a different direction of opening. It can be reflected in the x-axis, and both of those will have two real solutions because they will pass through the x-axis twice. When d is equal to 0, you only have one solution. And what do you think could be the graph for that one? So I hope you realize it should be your perfect square graphs, which only intercept the x-axis at one point, which means that the function only has one real solution. For example, if we have y equals x plus 2 squared, we know that the only x-intercept, so the only real solution is x is equal to -2. And finally, when d is less than 0, we know that the function has no real solutions. So notice how I had real in all of these. So that's that nature of the roots that we were talking about. And um, to see what other option we have, I first want you to consider this question of why does the discriminant determine the number of real solutions for us? And your hint is consider its role in the quadratic formula. So if we go back to the quadratic formula, that b squared minus 4ac is under the square root. So whatever value it has, it's under the square root. So if this is greater than, so D is greater than 0, that means we have a possible square root. We'll get a solution there so that you can add that solution once to negative b and get one solution, and then subtract it the second time and get two solutions. However, when d is equal to 0, this whole bracket is going to be 0. Or sorry, the whole square root is going to be 0. So then you just have that x is equal to negative b over 2a. So you only have one real solution, and that would be your real solution. It would just be negative b over 2a. Um, and finally, if d is less than 0, we have not seen how to find square roots of, for example, negative 5. But in math, these numbers are actually, they do have a name, and these are our imaginary numbers. So negative 1 itself is our imaginary number, and it's kind of like a cursive I. Um, and so negative 5, square root of negative 5 would just be uh, square root of 5, I. And consider that square root of 5 times square root of negative 1 is going to be square root of negative 5, or negative 5i, because of this definition. So in math we can say that they have two solutions when d is less than 0, but they would just be two imaginary solutions. So that's why we just say no real solutions. Um, and so the nature of the roots would also be whether they're real or they're imaginary. Okay, so now consider these graphs. So I'm just showing you now what those could look like using different parabolas. So when d is greater than 0 is when we have two real roots. So as you can see in both of these, we are passing through the x-axis at two different points. When d is equal to 0, we have the case of just one real root, which is just our vertex. And when d is less than 0 is pretty much the uh, parabolas that have been translated up or down, and they don't pass through the x-axis, so similar to these two. Now let's look at our first example where we have x squared minus 5x plus 6, and you're asked to first find the discriminant formula to determine the number of real roots. So let's start by setting up a, b, and c. So a is 1, b is negative 5, and c is 6. So the discriminant formula will tell me that b squared minus 4ac, we have negative 5 squared minus 4 times 1 times 6. So this will give me 25 minus 24, which is just 1. So d is greater than 0, therefore, uh, oh, then the number of real roots are 2. Now, factoring, here you can try finding two numbers whose product is 6 and their sum is negative 5, and you'll find that it's x minus 2 times x minus 3. So then the real roots are 2 and 3. So that's, again, from x minus 2 is equal to 0. So for that to be true, we need x to be 2. And now we're going to try to verify using the quadratic formula. So x is equal to negative b plus or minus. And now I've already done that square root part from my discriminant. So I can just write, let me just write the full thing first. B squared minus 4ac over 2a. So the reason I write that is now you can do, for your next step, show me, as negative, well, this one's going to be positive 5, plus or minus, and here, actually just 1, because you showed me that that is equal to 1 over here. Hopefully you got the correct answer there and it follows through, but we'll be able to check once we find our two roots. So here we have also 2 because a is 1. And I'm actually going to split this now. X1 is going to be, and square root of 1 is just 1, so it's going to be 5 plus 1 over 2, which is 3. And x2 is going to be 5 minus 1 over 2, which is 2. And yes, we actually got those same two roots here. So, well, the x1 and x2, remember, doesn't matter, but I can just switch these. There we go. Okay, and yes, so you can get the same answer from the quadratic formula, and we were able to confirm that we had two real roots. Now let's look at this next example where we have a quadratic formula, or sorry, a quadratic function, but now a is no longer equal to 1. So try this on your own now, and I'll come back to walk you through. Okay, so we're following the same steps as the question above. So here, just fill out A, B, and C again. So we have 2, nope, 2, 3, and -5. So using the discriminant formula here, we are going to get B D is equal to B squared minus 4AC. So 3 squared minus 4AC. And now this one is just going to be 9 um, plus 40, so 49. And D is greater than 0, so then the number of real solutions here are also 2. So now try factoring and find your roots, and we'll be right back. So here we need to try decomposition method. We need to apply decomposition method. So you'll get x minus 1 and 2x plus 5. So then our roots are going to be 1 and -5 over 2. Now, I already did the quadratic formula for us here, but we're going to start with x is equal to, and so I rewrote it this time with the numbers, so this way works as well, instead of writing the ABCs, because you're still showing me you know the initial setup of the quadratic formula. But if you don't include this and you make errors along the way, I will not be able to give you complete marks. Even for your partial work because you're not showing me that you know where to start from. So I can assume that maybe you made an error by not even knowing the quadratic formula. So that 49 we already knew, so I just wrote that right away. And now 49 has a square root of 7. So here, a little better form would have been if I split this up into x1 and x2. But I just wanted to show you that, yes, the two roots are going to be the same. And again, we were able to show that, yes, we have two real roots here, which was determined from the discriminant. Now, let's look at our perfect square example. And so here, before we even start, my question for you would be, what do you expect the discriminant to be? So the discriminant for a perfect square should be that d equals to 0 because we expect this to be of the form x plus or minus something squared. So let's test that out. So here we have A as 1, B is -6, and C is 9. So the discriminant tells us D is equal to B squared minus 4AC. But 36 minus 36 is equal to 0. And that's exactly what we wanted. So because D is 0, the number of real roots are 1. Only one real root. And factoring, you should have gotten that we get x minus 3 and x minus 3, which is just x minus 3 squared. So even if you didn't see this as a perfect square right away, if you tried decomposition method, you would have still got the same answer. And so the root here is just 3. So now we can verify using the quadratic formula, but our work here is actually really simple because x is equal to -b squared, or let me just write with the numbers, -9 plus or minus that b squared, -6 squared minus 4ac. But from the question above, we knew that that is equal to 0. So here, let me just finish my quadratic formula. So then this is actually equal to -9 over 2. Oh, I see my error. This should have been, sorry, negative b. So this should have been +6. Okay, perfect. There we go. And then we get 3. So that was a great way for me to check as well. So because I just saw that these two didn't match, I already knew there was something up with my answer. So I was more certain about this, so I double checked here. And again, that's also why it's always helpful to write the quadratic formula with A, B, and C, especially as you're still learning it, to avoid such mistakes with substitution. So, again, in this case, we were able to prove with the discriminant, with the factoring, and with quadratic formula that there's only one real solution. And we were also able to use factoring and quadratic formula to determine what that solution is. Now, for this last example where I've already told you there's no real roots, so I just want you to try to practice and see that you will like what problems like this could look like as well. So with knowing that there's no real roots, we expect D to be less than 0. So we're just going to check. So A here is 1, B is 4, and C is 8. So then D, we have 4 squared minus 4A C. And so this is 16 minus 32, so negative 16, which is, and here we would write because D is less than 0, therefore, I didn't define the function for you. You would just say there are no real solutions. No real solutions. Okay. And for our last problem today, you are asked for what value of m does g of x have exactly one root? And we see that m is used here instead of c. So, for this, we would need to use the discriminant because it's telling us the number of roots. We don't need to know necessarily what the root is or like to solve this in any way, for example, like with point of intersections, we just have to use the discriminant because it's the number of roots. So knowing that D is B squared minus 4AC, for this to have exactly one root, that means that D is equal to 0, which means that G of X is a perfect square trinomial. So we're essentially trying to find M so that that will be a perfect square. So here we have A is 49, B is negative 28, and C is M. And that's okay. You can have a variable in there. And so now when we solve, we have D is equal to negative 28 squared minus 4 times 49 times M. And we want this to equal 0. So in other words, we are saying that negative 4 times 49m is equal to, or sorry, the positive of it is equal to 28, negative 28 squared. Because these two are a subtraction, so they have to be equal for their difference to be 0. So now I'm going to evaluate. You can use your calculator here. So we have 196m is equal to 784. And if we divide, will give us just 4. And maybe let me just show my division there. You can always just use fractions to show that step. And so m is 4. So for value of m being 4, this function will have exactly one root. And you can always graph this using Desmos and confirm that it has one root and what its root is. So that was our lesson today for discriminants. So today's practice set is a lot of just trying out discriminants. So make sure you're comfortable with how to use discriminant. But because we've already been using in quadratic formula, I trust that this should just be a review. But as always, if you have any questions, don't hesitate to reach out and I'll see you all next class.